Alright everyone, so we're back. Part 4 of the Wreath network. I verified that we're up. We got connection. Hopefully we don't have to troubleshoot and go through those issues again, but it's a public network for anybody to use on TryHackMe, so we'll see from there. So what I did, I already got everything set up. I set up my HTTP server, transferred Nmap over to the compromised machine we did a while ago. We're about to do an Nmap scan to search for other IPs on the network, and yeah, let's do it. So here we go. Failed. Here we go. No target specified. I thought SN was a... Whoops. Maybe I don't have everything set up. Alright, so enumeration. We're on Nmap. Yeah, I just got the syntax wrong. Let's try that again. .1 through 255. So basically, here the SN switch, we're trying to find other networks or machines on the network so that we could pivot into and maybe get a higher access in a network. So we answered this question last time, excluding the out-of-scope hosts, and the current host, how many hosts were discovered? It's 2, but we discovered the wrong hosts. So I'm hoping this time we get a better result. We got a bunch more IP addresses, but some of them might not even be up. So we get a host is up, 10, 290, 100, 100, 150, 250, 200. So let's just ping those separately. See what we get. .100. All right, we're not getting anything from this. Let's try 150. Doesn't look like we're getting anything from that guy. Could also be a Windows machine, which is highly likely because we're doing a Windows box. So, oh, there we go, 250. We got a hit on that guy. We're getting ping responses, or ICMP echo, and then 200. I skipped 200. So, all right, so it's got to be 200 and 250. Oh no, we're on 200. So what's the other one? Maybe 100? We're just talking about 1. No, because they want... All right, let's try 100 and 200. 100 could be a Windows machine. No. Ascending order, what are the last octets of these host IP addresses? I guess we could try... Didn't we try 150 before? Try it again. 150 and 200? No. 100, 250. No. Is it 250 and 255? No. the hint. Yeah. I know, don't put a space. So for some reason, Nmap is not finding that IP address that we need. So here's the SN switch is used to tell Nmap not to scan any port and instead just determine which hosts are alive. We did that. Note that this would also work with CIDR notation. All right, let's try the CIDR notation. All right, note the host ending in 250 is the OpenVPN server and should be excluded from all answers. It is not part of the vulnerable network and should not be targeted. The same goes for the host ending in .1. Yeah, it's a default gateway. This too is out of scope and should be excluded from all answers. All right, so let's try the Nmap again, except with the CIDR. UDP payloads are disabled. And we get the same thing. We do know one though. We know one is definitely 200. Wait. 250. My bad. I keep saying 200. One is definitely 250. Alright. Let's do our little janky port scanner for I in not port scanner, IP scanner. For I and IP, do what was it? Echo dev TCP / 10.200.90. I need, I don't remember syntax. Go back up to the enumeration portion real quick. Or was it this one? No. Which one was it? This one. Here we go. This little guy. Range. Let's copy this. Kind of close. Nothing. Script TTL. Maybe we could get Netcat on here. Let's try Netcat. So curl p // what's my IP address again? This guy at port 443, and we want Netcat, and we want to name it Netcat tag. Whoops, forgot the taco. Let's get some music going. Hold on real quick. What do we want to listen to today? Some chill step. Put on one of my favorites. Volume, please. There we go. Let's do attack plus X. Why did I name it with attack? Move. Attack. Alright. I'm not dealing with this. I'm just gonna upload it again. There we go. Mod plus X. All right, now let's try this command with Netcat instead of ping. See what we get. Wait, what does it look like when we Netcat to a server to begin with? Netcat 10.200.90.200, right? Yep. And then let's do port 80. That. Let's try 250. Connection refused. Connection refused. So it doesn't valid Netcat. Okay, let's do my server that I got going on. My bad. At port 443. Cannot resolve. I forgot the HTTP. Jeez, forgetting everything today. So here we can see that we got a connection. My machine was just refusing it. Oh no. That was from before. Let's just see what we get. Let's do Netcat. Nothing. All right. Let's leave out the grep. Try that. Oh no, I need that and symbol. That's way too long. There you go. Anything. All right, let's move on to the next question. Because we know 250 is definitely one. See if we can get a hint. Scan the host. Which one does not return a status of filtered for every port? Smith lot. Well, we know that's 250. I'm pretty sure. No. We could brute force this. Let's look up some Nmap. Ping sweep from static binary. Since we're clearly doing something wrong. This tutorial focuses on ping sweep Nmap. Getting started with Nmap ping sweep. So we have to install Nmap. We can't do that on this machine. So there are two main Nmap flags we can use for ping sweep. These flags basically tell Nmap not to run a port scan after the host discovery process finds a device. The flags are SP and SN, where SN is the replacement of the old SP flag. The example below shows how to discover all hosts within the last segment or octet of the network. With the first three segments, octets 208, okay, cool, where X is the segment with all the hosts we want to discover. So they have SP. We used SN, which is the new version. Maybe we could try SP. I don't think we get a different result, but we can try. Another way to check all hosts within the octet is by implementing the wildcard. It is exactly the same as defining 1 to 255. Oh, that's cool. I didn't know that. And here they still didn't SP. You can look for available hosts in more than one segment. An example below. Nmap will check for a live host in the third and fourth segments. Oh, cool. Or that. That's easier. Let's try it again. Netcat. Let's try the SP. And then 10.200.90.200. Oh no, we want the star. SP doesn't work. We gotta use the SN. Could not resolve source address N. Jesus. Sorry, my wife's sending me pictures of the dogs. Am I getting the host wrong? I don't think it likes the 1 through 255. I mean, could not resolve N. Oh, we're doing Netcat. Ooh, where is my brain today? Cannot find Nmap payloads. How do you upload Nmap payloads? Upload Nmap payloads from static binary. The Nmap payloads file contains the protocol specific payloads, UDP probes. The Nmap payloads file contains the protocol specific payloads sent with some UDP probes. UDP scanning is difficult because most services don't send a reply to an empty probe, making it impossible to distinguish open and filtered ports. For some ports, Nmap knows a payload that is safe to send and tends to elicit a positive response. Alright, so we need the UDP payloads maybe? No. 100, 150, 250. Maybe it wants 100 and 150. Alright. Scan the host, which one does not return a status of filtered? I feel so dumb right now. Alright. Nmap tech P1 1 through 15,000 10 dot 200 dot 90 dot 100. I can't stop. I don't know. We don't need the UDP payloads. We're not scanning for UDP services. Let's go. That was a struggle. I don't know why I didn't try those two to begin with. I don't know if you were supposed to find this 250 one. It doesn't even mention it. which is weird. It's one or the other, but we'll wait for the results to come back. Alright, let's close this guy. And stop posting that. It's not what I want to do. Let's go. So after this question, let's see what's next. Let's assume that the other host is inaccessible from our current position in the network, which TCP ports in ascending order, comma separated below port 15,000 are open on the remaining target. Alright, and then after that, we cannot currently perform a service detection scan on the target without first setting up a proxy. So for the time being, let's assume that the service Nmap has identified based on their port number are accurate. Please feel free to experiment with other scan types through a proxy after completing the pivoting section. Assuming that the service guesses made by Nmap are accurate, which of the found services is more likely to contain an exploitable vulnerability? Alright. It's taking a little bit. Let's go. We should probably look up this sshuttle again. See what's going on that. I don't remember the syntax. See, sshuttle. Run setup.py. So we're just gonna, when we want to upload our proxy, we should probably just send this entire directory over to the machine. Wow, I should have done on like a T5. This is taking a while. That's alright, we'll just chill out. Pivoting. You guys might see my cat. This is Freya. She's my buddy. She likes to stand in front of the screens for attention. So we got, after enumeration, we got pivoting. Thinking about the interesting service. Not there yet. I don't want to cheat. Watch out, watch out. Lay down. Lay down. Lay down, Freya. There you go. Okay, so it's complete. All 50,000 ports scanned. They're all filtered. So it's the 150 port. Alright, scan this host. Which one does not return a status of filter? So it's going to have to be this guy. And while we're answering these next questions, we'll scan it. which CCP ports in ascending order, comma separated. All right, so now we gotta wait for this scan to get done. Don't rub on the microphone. So it's been kind of hectic past couple days. I've tried to get some studying in. It's been like what, a week since I did my last stream, but I did get a little bit of studying in with the PNPT. I got the Python portion done. It's going to be a slow process for a little bit. I think July is when I'm really going to kick it into gear and start doing... So spending a lot of time on this. I just bought a motorcycle, a Harley Sportster 1200 Custom XL. It's pretty awesome. It's my new way of getting to work since gas is so high. It's only going to cost me 1/3 of the price it is now to get to work, so just got to be careful. But other than that, I went through all of these. I can't stream these, or I would. I asked them. You obviously have to pay for all these, but yeah, I'm on the 5 stages of ethical hacking. If you do the CAH and a lot of the other certs, they usually go through this, the 5 stages of ethical hacking, but they go through passive reconnaissance, all this stuff. They don't, but not the way that I think the Cyber Mentor goes through it. This is going to be a lot more practical, obviously. It's all hands-on. The other stuff's just multiple choice. Yeah, still got, it's a big course, but it looks like it's going to be real nice. So yeah, if you do buy the all-in-one, you get these 5 courses. You get the practical ethical hacking, Windows privilege, Linux, OSINT, external. I think you get this one. Yeah, I think you get 1, 2, 3. Yeah, you get these 5, and then you get the voucher. And you know what I like about this? If you fail the first time, you could take the second time for free. They don't try to jip you with your money. It seems like they're really trying to make it affordable, if anything. So. This port scan's still not done. Watch this one come up filter too, after all this time. So I haven't really done anything on Hack the Box. I've just been on this site most of the time. That's where I've been doing all my learning. Which I think if you really get all into one site, it gets hard to kind of pivot over to another one, unless you're probably like do this for a living. Which is my ultimate goal, is to do this for a living instead of just a hobby. There it is. All right, so we got 80 open. We got RDP 5375 WS Dappy WS Man WS. Let's try to Netcat to that, to port 80. What was it? 10.200.90.150. We can try to look it up in the browser. See what we got. I don't know why I thought that would work. We're on another machine. We're in an internal network. But hey, you know, you gotta just realize those things. Alright, well, that's not working. No, actually, let's try it again, except let's, what is the get command? Get header. Get from Netcat. No, it's not what I'm looking for. Alright, I know an easy way to figure this out. Start up burp. Alright, but the WS man and WS dappy are the weird services. Which of the found services is most likely exploitable? It's talking about that one, 3389. There's a dappy. So you got 1, 2, 3. We have 4. It's at which TCP ports in sending order, comma separated below port 15,000 are open in the remaining target. Definitely no 80, 3389, and 5357. 5985. Alright, assuming that the service guesses made by Nmap are accurate, which of the found services is more likely to contain an exploitable vulnerability? 5985. Does it want a name or a port number? Alright, so probably the name. WS man. That doesn't fit. HTTP. Oh, duh. Now that we have an idea about the other hosts on the network, we can get started looking at some of the tools and techniques we could use to access them. Awesome, finally we're done with that section. Hold on. Didn't I open burp? Start it up. So here we go. Dashboard target proxy. Alright, we should be on 8080. This got updated. Alright. Let's catch one of our web requests. Google. This is what I want. This is all I was looking for. Nothing. Alright, nothing. Let's continue. Thinking about the interesting service on the next target that we discovered in the previous task. Pick a pivoting technique and use it to connect to the service using the web browser on your attacking machine. As a word of advice, sshuttle is highly recommended for creating an initial access point into the rest of the network. This is because the firewall on the CentOS target will prove problematic with some of the techniques shown here. We will learn how to mitigate against this ladder in the room. Although if you're comfortable opening up a port using firewall D, then port forwarding the proxy would also work. What is the name of the program running the service? I don't know. Let's find out. We gotta create one of those. This is gonna be painful, but we're gonna create a proxy. Let's nmap that. Service attack SV for enumerating services on port 80 and 10.200.90.150, right? Yeah. No such file or directory. What? Tap port 80 tap SV 90.150. Could not locate. I guess it can't do the SV, which is because it can't locate. Alright, well, so I need to create a proxy with sshuttle through here so I can access the site on my attacking machine. Okay, so let's try to go back to sshuttle and figure out that syntax again. So how would you use sshuttle to connect to this IP address with a username of pwned and a subnet of 16? What switch and argument would you use to tell shuttle to use a key file called privkey located on the current directory? SSH command tag H privkey. You are trying to use sshuttle to connect to 172.168.0.100. You want to forward the 172.168.0.24 range of IP addresses, but you are getting a broken pipe error. Which switch and argument could you use for this error? Alright, so to use example, so when using key-based authentication, the final command looks something like this. sshuttle tag R user, so this would be root and then the attacking address, and tag ssh command tag I and the subnet. The base command for connecting to a server with sshuttle is as follows: sshuttle tag R username address subnet. For example, in our fictional 172.16.0.x network with a compromised server at 172.16.0.5, the command may look something like this: sshuttle tag R user at this IP address. And then the subnet, we would then be asked for the user's password and the proxy would be established. The tool will then just sit passively in the background and forward relevant traffic into the target network. Rather than specifying subnets, we could also use the TAC-N option, which attempts to determine them automatically based on the compromised server's own routing table. Bear in mind that this may not always be successful though. As with any previous tools, these commands could also be backgrounded by the pending ampersand symbol at the end. If this has worked, you should see the following line: connected to server. Well, that's great, but what happens if we don't have the user's password or the server only accept key-based authentication? Cool. This is what we're going to do for our server to connect. But how do we connect? So we connect using this key with this subnet. Got it. But how do we connect to the other guy? When using sshuttle, you may encounter an error that looks like this. Broken pipe. This can occur when the compromised machine you're connecting to is part of the subnet you're attempting to gain access to. For instance, if we were connecting to 172.168.0.5 and trying to forward 172.168.0.0.24, then we would be including the compromised server inside the newly forwarded subnet, thus disrupting the connection and causing the tool to die. To get around this, we tell sshuttle to exclude the compromised server from the subnet range using the TAC-X switch. To use our earlier, okay, so I'm going to be using this command right here with this TAC-X, I think, because this is part of the subnet. Alright, let's see if we get this error first. So let's try this. Do we do it on my machine? TAC R, and then we can fill this part out. Roots at 10.200.90.200, and then TAC be the SSH command, right? SSH TAC ID RSA 10.200.8.200, right? And then the subnet we're connecting to, which would be, wait, why do I have two of those? Okay. And our subnet is sorry guys, hold up. Yo, I'm doing a stream. Hold on. Sorry, guys. Talk to me. so we're on the subnet. Sorry about that. One of my friends just called me. We got 10.200.90.0/24. SSH shuttle TAC L IP port TAC R port subnets. All right, so let's try that. TAC R. Argument IP mask port. Okay, I think I see what I did wrong. I think you really do have to put the TAC SSH TAC CMD. And then the SSH key file. And then the subnet. Local suit. Failed to flush cache unit. Free desktop.resolve1.service not found. Received non-zero return code 1 when flushing DNS resolver cache. Alright. Ooh. It was a different IP address last time I was on here. Maybe that'll... Maybe that's why. Yeah, it was not. It was 8. It's 90 this time. Let's try it again. Nope. I don't know what that means. Let's look it up. Because that's an error that they didn't even mention. SSH shuttle does not work. I guess we just gotta flush our DNS maybe. Alright, let's use this. Because it's talking about flush. A flush, so let's do a flush. Failed to flush caches. Unit dbus tac org. What? What does that mean? Activation via system D failed or unit dbus. Alright, let's see what Stack Overflow's got to say. I'm using Manjaro, Arch Linux, and I see the following error messages in my system log. This problem is related to network manager and system attack resolve d.service. After reading the Manjaro forums, configure network manager to not use system d attack resolve .service. Always gotta do some troubleshooting. Check if it is running and enabled. So let's do that. Or should we configure this first? So I gotta configure this file. I know he's using Arch Linux, and it still might be the same file location. And I gotta configure it with system d tac resolved equals false. Maybe. Let's keep reading. And then enable it. This solved errors from the coming up in the logs. Well, it solved the errors for coming up in the logs, but does it actually solve the error? I guess we're gonna find out. I don't like Vim. I don't even have that file, do I? No. Find tech. Work manager compd. Don't even have that file. That's not gonna work. Activation via system D failed. If I quote sshuttle. I've been using sshuttle for about 6 months on Fedora 32 and Debian 10 services. Everything was working until I did a scratch install on Fedora 33 on my Dell XPS 15. The RPM in the Fedora 33 repo is sshuttle. Okay, the version is no Arch. For my client, I can run nslookup, IP address, and fully qualified host names from my client successfully. IP addresses return fully qualified domain names, and fully qualified domain names return IP addresses. I can SSH to remote machine by IP address. I can open a web page on a remote machine using its IP address. Yeah, I can do all that too. I am unable to run SSH to any machine by fully qualified domain name. Open a web page to any machine by fully qualified domain name. The following command is what I use to establish a connection successfully to a server. Just a connected message. Tech Python. I've tried without specifying Python flag, but that does not help. Anyone got this to work correctly using Fedora 33 things. So it looks like he's specifying Python and then giving it the Python environment. Sure. Let's try that on ours. Wait. Python 3. That should be my Python environment, right? It's cd user bin should be my Python environment. Yeah, let's just try it. Whoops. TryHackMe, Wreath. No such file or directory. This is for users in restricted shell on the server. Try specifying just the name of the Python executable. If Python's not in your path, you cannot run it. Fatal. Server died with error code 127. This error code likely means that we were not able to execute the Python executable that specified TryHackMe. So what if you just do TryHackMe? Does it just run Python that way? It didn't like that. Connected to server. Oh, it does say I'm connected to the server. But it says failed to flush cache. Receive non-zero return code. So let's background it. Is that what I'm supposed to see? Is it client connected? It doesn't say disconnected. Oh yeah, it does say disconnect, broken pipe. Alright, so let's try the TACX trick. 10.200.90.200. Fatal SSH connection to server. Exited would return 255. SSH command. Tag I RDSA. Unit dbus tag org resolve 1.service. Okay, so am I still? I'm still connected. I might watch a quick video on this because I'm not understanding what's going on. So let's try to access that just to see, because it still says I'm connected. 200 dot. I don't think this is gonna work. I'm still using burp. The Django setting. Page not found. All right, yeah. Let's see how to do this. See how to set up the sshuttle.
Hey everyone, welcome back to another video on the Wreath network on TryHackMe. Today we're going to be taking a look at task 18, Get Server Pivoting. Before we dive into the task, I do want to scroll up and show that this did update, so we can see we've got our 2 IPs that we found, and we can see that we are going to be attacking presumably this 150 next, and I believe that's what we're going to be diving into with this task. Thinking about the interesting service on the next case, we could use sshuttle, and yeah, we can see that it's even advised down there. I'm going to do an initial curl of the website to see what we're working with, 10, 200, 72, 150, just to see.
I could have just done a curl. You know, I'm going to do that right now. So curl 10.200.150. I don't know why I didn't do that. And we get head. Like CSS info, it looks like. Here's the HTML 404. Using the URL conf to find. You're seeing this error because you have. All right. PS aux PS aux grep sshuttle. Oh my god. Zoom out. Thank you. So we got 3 of them running. So sudo kill tech 9 2240 2243 and 2244. All right. Try it again. I'm still getting the same thing. So that might be a good thing. The sshuttle might have worked the way we did. Let's see what he got.
And we can see that we're working with a service called GetStack, which is actually going to be our first answer here. That's a nice way that if you don't want to do any pivoting right away, you can see.
Oh yeah. Yes, it is right there. And then we did see this registration login on my system. So maybe the sshuttle did work. And I just didn't realize it was working. Alright. It makes me happy. So there was this one. Get stack. And then I'm going to go to that registration on my site. So let's reapply our sshuttle command, even though it's gonna give us a weird code while flushing DNS. We'll go back to here. We'll go to registration / login. Ooh, there it is. Okay, so the proxy did work. The proxy worked. Awesome. We did it right. All right. I just need to confirm that because I was never done it before. So when navigating to this URI, we are given the following login page. Username, password. Do these default credentials work? Admin. Probably not. Too easy. Yeah, no. It don't work. Nay. Shucks, couldn't be that easy. Yeah, I just said that. Back to the drawing board. Use the command search exploit service name. Alright. So let's clear this. Since our proxy is in the background, we can clear this and we do search exploit for git stack. And we got an RCE for the web apps. Alright, let's bring that guy down. So search exploit attack mirror, and then we want this path. No, I want the one in Python. This one's a specific, the one in Python's a specific version. Alright, let's try it anyway. Alright, so let's rename that to get stack exploit.py. I did that. You will see that there are 3 publicly available exploits. There is one Python RC exploit for 2.3.10 of the service. What is the EDB ID number of this exploit? What? EDB ID number? 2.3. Let's look that up. EDB ID number 43777. All right. In the previous task, we found an exploit that might work against the service running on the server. Make a copy of this exploit in your local directory using the command search exploit attack m. Did that. Unfortunately, the local exploit copies stored by search exploit use DOS line endings, which can cause problems in the scripts when executed in Linux. Before we can use the exploit, we must convert these into Linux line endings using the DOS2 Unix tool. Never heard of that, so okay. This can be done manually with the sed if DOS2 Unix is unavailable. Alright, so we got some regex. Let's try running it first. I don't believe him. Oh no, did it kick me off? That's annoying. Two 579. All right. What's going on? We're just getting into the good stuff. Did it reset? Yeah. Alright, reset. We're gonna have to reset this guy, probably. Or open VPN. That's the second time it's done that. It did it right before I logged on. So let's try to give it a ping. Yeah, nothing. Alright. Let's end this. Px aux grep open VPN sudo kill tech 92635. Alright. We shouldn't have access now. No access. We should have access now. Access. Not the dashboard. Learn. I'm running. Let's give it a ping. Should be working. And it's probably not going to work. Let's restart the VM. Could be my side. I hope it's my side. Just VM issues. I just really want to get done with this network. There's so much more. All right. All right. We're up. We're booted. Sudo open VPN. Tech Wreath. Initialization complete. Let's ping this guy. That is not the right IP address. 200.90.200. Okay, cool. Cool. Thank God it was just my VM. Let's do a CD STF, TryHackMe, Wreath. Alright, we're pretty much right back where we need to be. So, split this horizontally. And let's run a SSH tac I ID RSA root at 10.200.90.200. We're back in. Ooh, I forgot to take screenshots of the. That's all right. Of my port scans. That's okay. All right, so let's do the SSH shuttle. Is it still here? It should still be here. No. So SSH shuttle tac R and then root at IP address. So 10.200.90.200 tac SSH tac CMD. And that would be SSH tac I ID RSA underscore shit. It'd be this. $200, and then it'd be the subnet, which is 10.200.90.0/24, and we want to exclude the box that we're going on, which is 10.200.90.200. What did I get wrong? CMP. All right, well, we're connected. I forgot to background it. Let's see if it's still running. No. Okay, so we're good. And let's send that to the background. And like do its little error thing with the DNS, which doesn't really matter. So Firefox. Get back to that website. So 10.200. I cannot remember that. Should bring us here, and it should go to this page. Why did it do that? 10.200.90.150. Okay. Get stack. Look at the information at the top of the script. What is the date? On what date was this exploit written? What date? So let's look at our script. So subtle. So it was written 18 January 18th, 2018. As this is a Python script, the version of the language used to write the software matters. Many older exploits are still written in Python 2. These exploits tend to be incompatible with Python 3 interpreter and vice versa. Before we can do anything else, we need to determine whether this exploit is written in Python 2 or Python 3. A quick way of doing this is to look for the print statements used to echo output to the console. If there are no round brackets, okay, wait a second. Print statements used to echo output to the console, yeah. If there are no round brackets, print hello world, then the exploit will be Python 2. Otherwise, the exploit is likely to be Python 3. Of course, this is far from the only way to check, but it will work for our purposes. Alright, so where it's Python 2. I think I have Python 2 installed on this though. Yes, I do. Alright. But you know what? I want to take a screenshot of this. I can go back and do the port scans, but I kind of want to keep up with the screenshots a little bit. Yeah, this 250. This needs to go away. Does it? Yeah. That's just me scanning the same machine again. It won't let me paste it. Seriously? Alright. Screw it. I'll just go back and figure everything out and do the write-up. Bearing this in mind, is the script written in Python 2 or Python? It's been written in Python 2. That's a cool little trick. I didn't know that. I've only ever done anything in Python 3, so it's good. Now that we know which version of Python we're dealing with, we can execute it on one of two ways. Using the appropriate interpreter directly, Python 3 / Python 2, adding a shebang line in at the top of the exploit. A shebang tells the Unix program loader which interpreter to use to run a script. Shebangs always start with the hashtag #, exclamation mark. You then specify the absolute path to the interpreter. So it'd be that guy or that guy or that guy for Python 3, 2, or Bash or Go or whatever language you want to use. Alright, so this means if we execute the script using the exploit.py, it will be executed by the correct interpreter. Add an appropriate shebang to the exploit at the very top of the file. So it wants me to add this shebang to the top of the file. So we'll do that. I was just going to use Python 2 directly. So those are all commented out. So we'll just do was user bin Python 2. This, what we'll do to the top. I don't know why I did it right there. I have a feeling this is, save that. Did that. Let's have a look through some of the key sections of the code. The script is not designed to be fancy. It does what we need it to do and nothing more. All configurations are done with the code by literally editing the script. So it's important that we understand the options available to us. These can be found in lines 23 to 31. So the IP command, who am I, repository RCA, and then CSRF token. Realistically, we are only interested in the first two variables here, as the other position options should be fine at their default values. The two variables we care about are IP and command, allowing us to specify our target and the command to run, respectively. Set up IP to the correct target for your choice of pivoting technique. If you used sshuttle or one of the proxying techniques, this will just be the IP of the target. So set the IP of the correct target for your choice of pivoting technique. If you used sshuttle or one of the proxying techniques, then this will just be the IP of the target. Alright, so we use sshuttle, so we're just going to use the .150. If you used a port forward, then it will be localhost chosen port localhost 8000. Cool. For the time being, we will leave the command as it is. Who am I? It is a good is as good. Who am I is as good a command as any to confirm that the exploit works. The bulk of the middle section of the code is taking advantage of the improper access controls which make this vulnerability possible. We will not cover this in detail in order to keep this task relatively short. However, reading through the exploit and trying to understand it would be highly advisable. We are, however, interested in the last 6 lines of exploit. These create a PHP web shell, which is PHP system post A, and echo it into a file called exploit.php under the web root. This can then be accessed by posting a command to the newly created webexploit.php file. For the sake of not spoiling things for other users, we are going to alter this before running the script. We can leave the payload as it is, but we will alter both instances of exploit.php in the script to be exploit tag username.php, for example. Oh, so we have to load this script onto the target machine we're on. Yeah. Having added a shebang, changed the target, and updated the name. Okay. Name of the exploit.php file. The exploit should now be fully configured, so we will perform the exploit in the next task. Just to confirm that you have been paying attention to the script, what is the name of the cookie set to in the post request made on line 74? Line 73 if you didn't add the shebang of the exploit. So we got requests. Let's change this IP to 10.200.90.150. We'll leave that as who am I. We'll leave those. So it's going to print get user list. And it's going to try request.get IP. So it's going to request the rest/user. I guess that's a directory in the get stack program or web app, and then user list equals r.json. They'll know what the .json does. It probably converts it to JSON. and user list dot remove everyone except pass. If length of user list is greater than 0, username equals user list. 0. Okay. So if whatever JSON pulls down and it finds the user list, it'll pull down, or it finds a name, it'll pull down the username equal to the very first one in the list. Print found user username, and then it'll print it out for us. Otherwise, request post. So we're gonna post username. We're gonna post username and password. Your username as username and password as password to create a user. And if not, user created in r.text and not user already exists in r.text, print cannot create user. So if this user is already created, it won't do it. And if it's in, and if it already exists, it won't do it. And it'll exit. And then it'll go r equals request.get, and we'll try to get this new directory. And then if it's true in r.text, we'll print web repository already enabled. Else, and we'll enable the web repository. We're going to try to attempt to by using a put in the data enabled. If not, web interface successfully enabled. In r.text, print cannot re-enable interface. And I'll exit. And we're going to print get repository list in the rest repository directory, and I'm going to translate that into JSON. And if length of repository list is greater than 0, repository equals that name. Print found repository, and it'll print out right here. Else, print create repository, and we're going to try to recreate a repository, and it seems like it kind of just does the same thing for the repository and all that good stuff. So the cookie in the repository we're trying to create is a CRF token. CRF token data equals name repository CRF middleware token. Middleware. That's not it. $74, $75. It's not in either one. It's cookies. CSRF token. Alright, so this is good. We understand what the script is doing. So PHP is a server-side ran code. So it will run the code on server side, and then once that code is run, it will give us the response on our end. So we can actually inject stuff into the PHP server and manipulate the data, and that's exactly what this exploit looks like it's doing, because we're getting the user list, and if not, we're going to try to create a user, and if we can't do that, we're going to go on and we're going to try to get a repository list, and if not, we're going to try to create a repository, and so on. So cool. Save this. And we did change our IP, and we're leaving who am I. Okay. So we need to go over here. Let's shouldn't I just be able to do it on my machine? Let's try it on my machine first. Yeah, alright, that's what I thought. We were able to. And you can see it's a Windows machine, NT Authority system. What else did we get? So get user list, found user Wreath, Wreath. So we got a user. The web repository is already enabled. Found repository website, add user to repository, add user to repository, disabled access for anyone, create backdoor in PHP. Your Git stack credentials were not entered correctly. Please ask your Git stack administrator to give you a username/password and give you access to this repository. You have to enter credentials to where execute command NT authority. So we should be able to log in with username and password. Username, no, password. No, didn't work. Alright, so we executed who am I. It's a Windows machine. So we can set up a Netcat listener and have it call back to our machine. So in the previous task, we had a look through the source code of the exploit we found, identified the lines which need to be updated, then made the necessary changes. It is now time to run the exploit. We ran it. I got that. Not only did the exploit work perfectly, it gave us command execution as NT Authority System, the highest ranking local account on the Windows target. From here, we want to obtain a full reverse shell. We have two options for this. We could change the command in the exploit and rerun the code. We could use our knowledge of the script to leverage the same web shell to execute more commands for us without performing the full exploit twice. Option number 2 is a lot quieter than option number 1, so let's use that. I was just going to change the command, but okay. Understand red teaming. The web shell we have uploaded responds to a post request using the parameter tag A by default. This means that we have two easy ways to access this. We could use curl from the command line or burp suite from the GUI option. With curl tech x post IP web exploit username.php. And we don't have to do this because we can run it on our own machine. Tac D A equals command. So I like the curl method. Note in the screenshot, getServer.thm has been added to the etc host file on the attacking machine mapped to the target IP address. We first turn on our burp. We could do a burp suite. Let's do burp suite. Burp. Nope. Do not update. Let's go to proxy intercept on. We need to turn our proxy on our web browser. Cool. Okay, so we first turn on burp proxy, burp suite, and navigate to the exploit URL. So what is our exploit URL again? It is... Maybe I should have finished reading the code. Where does it run? Command. Okay, it runs command here. So we can navigate to this guy. Oops. Ten dot 200.90.50. Okay, we get our cookie. Ooh, yeah, okay, maybe I did ruin it for other people. I didn't really understand what was going on until just now. So by me putting that exploit, anybody can just run that. I should have changed this file name. Well, oh well, it's already on there, so whoever's doing it, you're welcome. Alright, so what does he want us to do now? So we then press Control R to send the request to repeater on the top menu. We can do that, or we can just say action send to repeater. Cool. And then next we change the get on line 1 to post. We then add content type. Header to line 9 to tell the server to accept post parameters. Content type, application, X, www form, URL coded. And finally, on line 11 we add a equals command. Okay, let's see. So I got a cookie. Let's try it anyway. A equals, who am I? Yeah, 200. Sorry if it's small. We can try to make the letters bigger real quick. User options, display, font size, 16. All right. Yeah, it didn't make the actual font size bigger. What? Maybe this one will do it. There we go. Okay, I changed it. So cannot execute a blank command. Do I drop the quotes? Connection close. Let's get rid of these guys. What am I doing wrong? Oh, I gotta change it to post. Still says I have a blank command. Content length. There it is. NT authority system. Apache 2.2.22. OpenSSL. Ooh, Python. And PHP. So yeah, we got that. Cool. With 2 methods available, pick your favorite and we'll aim for a shell. Alright, let's try the curl real quick. No, we'll stick with the burp suite. First up, let's use some basic enumeration to get to grips with the web shell. What is the host name for this target? The host name for this target is this. Oh no. T. What is the host name? Did it say it in my exploit? So we found user T Wreath. God, I'm sorry. I don't know. I keep clicking on that. I don't know the host name. hostname command. Is that a command? Oh. $90. Oh no, that's my host name. I need to post host name, get serve, copy, just copy, get serve. What operating system is the target's? What's the command for operating system again? Oh, it's Windows. I already know it's Windows because NT authority. What user is the server running as? NT authority system. NT authority system. Cool. Before we go for a reverse shell, we need to establish whether or not this target is allowed to connect to the outside world. The typical way of doing this is by executing the ping command on the compromised server to ping our own IP using a network interceptor Wireshark TCP dump to see if the ICMP echo requests make it through. If they do, then the network connectivity is established. Otherwise, we may need to go back to the drawing board. Yeah, let's TCP dump tac I interact with ton 0 ICMP. And then we'll ping my machine. Sudo listening. Let's ping 10 dot, what is my IP address? There's my IP address, close that. Maybe I need to URL encode it since I have a space. Yeah, let's try that. So I got a timeout. Okay, well, it did ping, but it's not reaching my machine. What about this guy? TCP dump not found. Huh, I wonder why it can't reach my machine. We don't have to use N3 because Windows just will do 4 pings and stop. You know what? We'll try it. Yeah, we're not getting anything. This will send 3 ICMP ping packets back to you. How many make it to listener? 0. Looks like we're going to need to think outside the box to catch the shell. We have 2 easy options here. Given we have a fully stable shell on .200, we could upload a static copy of Netcat and just catch the shell there, which I already uploaded Netcat. We could set up a relay on .200 to forward a shell back to a listener. It's up to you which option you choose, although for sake of practice, a SOCAT relay is suggested. However, whichever way you choose, please be mindful of other users at earlier stages of the network and ensure that any ports you open are above 15,000. Before we can do this, however, we need to take one other thing into account. CentOS uses an always-on wrapper around the IP tables firewall called Firewall D. By default, the firewall is extremely restrictive, only allowing access to SSH and anything else the sysadmin has specified. Before we can start capturing or relaying shells, we need to open our desired port in the firewall. This can be done with the following command: firewall tech command tech zone equals public, add tech port TCP. Substituting in your desired choice of port. In this command, we are using 2 switches. First, we set the zone to public, meaning that the rule we apply to every inbound connection to this port. We will specify which port we want to open along with the protocol we want to use. With that done, set up either a listener on relay or a relay on 200. Shall I go the listener or the relay? I've never done the relay before, so maybe I should try that. We gotta go back to SOCAT. Do we have SOCAT on here? No. We're gonna stop that. You know what? No, I'm gonna do my Netcat. I already have Netcat on there. Tech LVMP. Let's do ports. Five, 55,555. Exploitation. Alright, so looks like we're going to need to think outside the box. Alright, well, this is a good command to have. I'm going to copy that in my notes, if it lets me. We're going to add a section called firewalls. IP tables. And this is add port for relay connection for pivoting. Let's make this 16. We'll make this guy like green or something. All right. Let's go for reverse shell. We can use a PowerShell reverse shell for this. Take the following shell command and substitute in the IP of the web server and the port you opened in the .200 firewall in the previous question where it says IP and port. So let's open that up. Got ahead of myself. Firewall, tech command. 1, 2, 1, 2, 1, 2, 3. Success. All right. Now let's listen since we're open. Reverse shells on Windows are so long. New object. System.net socket. IP port. Put that in there. Stream. Client get stream. All right. So put this in here. And substitute this guy. IP is 10.200.90.200. Port 23. All right. As this is a web exploit, we now have to URL encode the shell command. If you're using Burp Suite, you can do this by pasting Command A and Control U. So, okay. Let's Control U. There we go. URL encoded. If you're using curl, then there are a variety of options available. Curl does provide a tech data, tech URL encode. Wow, it's convenient. Switch, however, is often easiest to just use website to encode the shell command, then copy it to in with the tacd switch. Oh no, I forgot all this. Let's try again. 10.200.90.200 port 555. There it is. All right. We're listening. Let's send it. No response, so we should have caught it. Connection from. Who am I? Nice. We're in. We're in. Let's stabilize this bitch. Let's stabilize it. In the last task, we got remote command execution running with the highest permission possible on local Windows machine, which means that we do not need to escalate privileges on this target. In the upcoming task, we will be looking at the second teaching point of this network, the command and control framework, Empire. Before we do that, though, let's consolidate our position a little. From the enumeration we did on this target, we know that ports 3389 and 5985 are open. This means that using an account with the correct privileges, we should be able to obtain either a GUI through RDP, or a stable CLI shell using WinRM port 5985. Specifically, we need a user account as opposed to the service account which we're currently using with the remote desktop user. With the remote desktop users group for RDP or the remote management users group for WinRM. A user in the administrators group trumps the RDP group, and the original administrator account can access either at will. We already have the ultimate access, so let's create such an account. Choose a unique username here. Your TryHackMe username would do. And obviously pick a password which you don't use anywhere else. First, we create an account itself. Net username password add. Right? So we'll do net AAL dapps username password 1 password 1 add. All right, we should be able to RDP. Okay, and then next we add our newly created account in the administrators and remote management users. Net local group administrator. Net local group administrators. And then username add. Net local group administrators. And then username /add. Oh, I forgot the /add. My last one. Probably didn't work. Apps. Password 1 /add. Am I forgetting something? Net user. Net user password 1 /add. Okay, and then this be net local group administrators. Local group administrators LDAPS add. Oh, yep, that'll work. And then net local group was it remote management users. Remote management users /add. Nope, I wrote that wrong. I gotta include my username. Can I copy and paste? Okay, we should be able to go RDP into this guy now. We can now use this account to get stable access on the box. As mentioned previously, we could use either RDP or WinRM for this. Whilst the target is set up to allow multiple sessions over RDP for the sake of other users attacking the network in conjunction with memory limitations on the target, it would be appreciate it if you stuck to the CLI based WinRM for the most part. We will use RDP briefly for the next section of this task, but otherwise, please use WinRM when moving forward in the network. Alright, so let's access the box over WinRM. Never used it before, so cool. Sudo gem install evil WinRM. Okay. This does not come installed by default on Kali, so use the following command. Let's see if I have it. I might have it. Evil tech WinRM. No, I don't have it. So sudo gem install evil WinRM. Gem. Dope. 13 gems installed. All right. So evil WinRM, TAC-U, username, TAC-P. Let's just edit this as we go. I think it should work on my machine. Let's see. Password is password1. You might have to do that so cat setup. 10.200.90.150. Establishing connection to remote endpoint. Nope. Our sshuttle is working great. Alright, so I'm going to take a quick screenshot of this. Maybe it'll let me paste it into my screenshots. Probably not. Yeah, I don't know why it's doing that. I gotta fix my permission issues. Yeah, so we got a nice stable shell right here. Okay, so if you used an SSH port forward rather than sshuttle to access the Git server, you will need to set up a second tunnel here to access port 5985. In this case, you may also need to specify the target port using the TAC-P switch. Alright, note that evil WinRM usually gives medium integrity shells for added administrator accounts. Even if your new account has administrator permissions, you won't actually be able to perform administrative actions with it via WinRM. That's weird. Now let's look at connecting over RDP for a GUI environment. Yeah, he uses free RDP. I like the Remina. So yeah, let's do that. Let's do the I just find this a lot easier. RDP 10.200. Username. what was the domain again? Get serve. Get tag serve. Get tag serve. All right, we're on. Let's go to our file system. All right. Ooh, users. Yep, here I am, administrator. NSJA. Public Thomas TryHackMe. Oh, permission. Let me on anyway. We got documents. What was recently accessed? Nothing. Nothing in the documents. All right. Git stack. Install. All right. What do we want to do now? All right. Note that as this is a command line tool, passwords containing special characters must be enclosed in quotes. Okay, mine's not a command line tool. Right. When creating a shared drive, this can be accessed either from the command line as TS client or through File Explorer under this PC. Resize the windows, set specific size for targets, don't resize automatically. Enables clipboard, creates a shared drive between the attacking machine and the target. This switch is insanely useful as it allows us to very easily use our toolkit on the remote target and save any outputs back directly to our own hard drive. In essence, this means that we never actually have to create any files on the target. For example, to share the current directory in a shared called share, you could use /drive share with the period, referencing the current directory. Wow, okay. Yeah, I'm definitely gonna close out of this. Because I don't think Remina can do that. I just use it because it's an easy way to RDP from Linux. Send hello world. All right, let's log out. And download that tool. Let's open up another one. sudo apt install that. Guess I want to continue. Yeah, we're going to create that share drive. So we can add all of these. We'll do the dynamic resolution, and we'll do enable clipboard, and we'll do a local directory. So let's just for shits and giggles, because we're gonna stick mainly to the evil WinRM, but just to learn how to use this real quick, we want 10.200.90.150, and then the user we created, LDAPs, and password was password 1, and we want the dynamic resolution, and we want this guy. Which local directory, right? We're referencing the directory we're already in. Yeah, and then comma share name is going to be sharing is caring. All right, let's see if that worked. Nice. That's really cool. Note that the name of the share will change according to what you select in the /drive switch. A useful directory to share is the user share Windows resources directory on Kali. This shares most of the Windows tools stockpiled on Kali, including Mimikatz. Useful directory to share. Okay. Alright, which we'll be using next. This would take full effect, the full command. Username, password, plus clipboard. Oh, I forgot our clipboard. Yeah, so instead of sharing our current directory, which is the Can't even see it anymore. The CTF TryHackMe Wreath. We just changed that. Cool. Got it. With GUI access obtained on our Windows resources shared to the target, we can now very easily use Mimikatz to dump the local password account hashes for this target. Next, we open up a command.exe or PowerShell window as administrator. Right-click on the icon and run as administrator in the GUI. Enter the following command. Alright, well, let's just redo this. Let's log out real quick. And let's go share that. Share that directory, which was what? Windows user share Windows resources. Okay, now that while that's loading up, we can go what's up, Free? I'm almost done. As soon as I'm done with this little part, I'm gonna call it for a night. TS client. Where did TS client come from? Run as administrator. So TS client. Did I make that a capital? Where did he get TS client? What? If you used a different share name, you would also need to substitute this in equally. Alright, let's do that. So our share name is sharing is caring. Yeah, there. And then we're gonna access that. All right, there we go. Sudo apt install. When Mimikatz loaded, we next need to give ourselves a debug privilege. and elevate our integrity to system level. This can be done with the following commands. Privilege debug and token elevate. Elevate. Okay, so cool. We did it. Looks like. And if we could log Mimikatz output with the log command, for example, log c windows temp mimikatz.log would save the Mimikatz output into the Windows temp directory. This could also be saved directly into a Kali machine, but be aware that the remote destination must be writable to the local user running RDP session. We can now dump all of the SAM local password hashes using LSA dump SAM. Cool. SAM. Whoa, alright. Huh. Cool. Do we see the administrator? So, NC authority. Ah, administrator hash. Okay, awesome. Let's copy that. I'm gonna save it in our directory real quick. Let's nano admin hash text, and we'll do discovered on machine 10.200.90.150 using Mimikatz administrator hash. All right. So cool. We did that. Authenticate with WinRM, we did that. Authenticate with RDP sharing a local copy of Mimikatz, then dump the password hashes for the users in the system. What is the administrator password hash? That. What is the NTLM password for the hash for the user Thomas? So let's look for Thomas. Here it is. All right, let's add that to our notes too real quick. Thomas. And let's rename that to discovered hashes dot text. So that'd be discovered hashes dot text. What is Thomas's password? I bet it's password. No. Okay, so we'll just run it through Crack Station, since that's what it recommends. I could use John Ripper, but it says it gets cracked in Crack Station, so let's do that. Crack Station. Not a robot. I less than E Ruby. Alright. Alright guys, I'm about to wrap this up. It's getting a little late. This was a way better section than the last one. There's a lot more interacting and whatnot. Less troubleshooting. There's still a little there, but we got through it. And we learned a lot. I learned a lot. I'm still constantly learning. I'm going to try and do this again tomorrow night. We'll see what happens. So, yeah. We'll pick it back up another time, part 5. A lot more parts than I thought it was going to be, but thanks for watching.